Hello everyone, I'm Jason Sikes, aka the Tech Rancher, and this is my homework solution for lesson number 30, 31, 32, 33, and 34. These courses are by the famous Paul McWhorter, who makes several different types of electronic engineering courses that you can watch on YouTube by looking up Paul McWhorter or learn more information on his website at www.toptechboy.com. Check him out and let him know that I sent you. That means a lot to me if you would. Alright, enough promoting about Paul. Let's talk about what these homework solutions were. I know this is kind of combining 5 into 1, but they all build upon each other. Which when I started writing lesson number 30, it was already what lesson number 31 was going to be about, which led to lesson number 32. Long story short, it did all the lessons right there within it. And so here we are. All right, what I'm going to do first is I'm just going to go ahead and show you the solution. So let's just bring this little guy up here bigger. Go to my board view and let's just bring him up here. I want you guys to be able to see this really well here. Just dive it in there. Okay, I'm going to turn it on. Okay, one of the requirements was that Paul wanted it to not be hooked up through the USB, to be battery operated. So that's going to be one of the things that we're going to do. And another one was that he wanted our Pico W to be as a server to run an API call. That's another thing that we're going to do with this. And see here, let me just pull up myself here. Yay, there you go. I'm just going to talk about this real quick while I'm showing this. Okay, and then that was lesson number 30 was to do an API call using the Raspberry Pi Pico W as a server. Lesson number 31 was he showed us how to use open weather. Sorry, I had to look at my notes. He showed us how to use open weather API, which that's actually what I was doing for the homework for lesson number 30. After several different ideas, that's the one I ended up going with because I thought that would be useful for me to go ahead and make one of my Pico W's into that. And then that was number 31, and 32 was he wanted us to have a visual indicating. I went ahead and put a second SSD 1306 on it, and you'll see here a little bit what that does. And then on number 33, he wanted us to convert an algorithm from the HSV Color Wheel and from degrees through degrees, and so the top 360 or 359 all the way around back to 0, or reverse that, sorry, 0 from counterclockwise all the way back up to 359, and being able to within any of those degrees know what that color value was. And then that was lesson number 33, and 34. Paul shows his solution to that. Paul did a great job on 33 getting us prepared. If you remember how to do any of his other slope indications or point slope indications, you would have been able to figure out what he showed you from 33. You'd have been able to do 34. You'd have been able to do it before 34 came up, and I was able to do it before 34 came up. And then when 34 came up, I went ahead and made the library like he said for us to make a library. So I went ahead and made a library. I'll show you it too. All right, enough talk. Let's get over here and show the solutions. I'm turning it on. Okay, the on button's on, and we're waiting here. It's making its API call. It's connecting. I should have put some indications on it, but it just takes a little bit of time. Boom, there you go. There it is. Okay, so let's zoom in. I'm reaching over here and repositioning myself and zooming in and hitting the focus. All right, just read it down here. Ranch Network. Hello, Monette. And it gives our day, which is Thursday, and the recording date actually too. So September 21st of 2023. And it was going to update. It's going to update in less than 5 minutes, 4 minutes and 32 seconds. And then that's on well, if you're looking at it, it'd be on your right side, in my left. But anyway, then you go to your left side. Wait, sorry, correction, take that back. Left side is what you guys see. Right side on me That's why I got confused. And then on the right side, left side of me, is the display screen that's showing the information that we use through the code, taking the JSON and getting the data out of it and then having it display onto the SSD. And then I had the time that it was grabbed, being displayed right there. It says the last update, the temperature that it's showing, the conditions outside, or where it was indicated, which is clear skies, which is correct outside here, and the winds at 10 miles per hour at 170 degree. That's from, so it's blowing from to the opposite of that, add 180 to that, so that would be 40. Yep, and so that would be the opposite side of that, where it's blowing to, and that's where it's from is 170. Aviation guys would probably know that too. The LED, the RGB LED is less than 33, making the algorithm, and less than 34. Paul wanted us to go ahead and convert that to that. And there you go. It's really, really hard with my lighting, but it is actually yellowish green. I'm a little colorblind on green, so light green like this is hard for me to know. It looks white. Just letting you know. But from if the calculations is correct, that's what it should be. Yeah, that's why I said that. All right, let's get to the code here. Let me minimize this guy here. I need to go back to this setting. Sorry about that, guys. Bear with me here as I'm repositioning stuff. I'm going to leave that down here for us. And, well, maybe not, because it's right in the way of everything. Let's see. There we go. All right, and I'm going to make this code a little bit bigger. It makes everyone happier along with me. And here we go. So it's a weather display. And we're bringing in our libraries. And with our libraries, we're bringing in MicroPython, the const, because I like to throw all my constant values into that. Therefore, it's not going to change. And then from the library machine, bringing in the modules of the pin, pulse width modulating, and the I2C. And bringing in network, being able to turn our Raspberry Pi Pico W into a server. And then we're bringing in time, or U-time as in time, and then U-request. This is the way how we turn our server into requesting data from the internet, from grabbing different websites. We're going to use U-request to grab an API, automated programming interface. We're going to grab that and we're going to bring it back, and you can get them in multiple different data back, but we're grabbing it in the JSON, and a JSON formula is a little bit like a Python dictionary. Well, pretty much kind of is a Python dictionary, and so you step into it just like you would with a Python dictionary, like in keys and values. So we're going to grab the keys to get the values out of that. So that gives you a quick breakdown of an API, automated programming interface. And then importing cat food. Cat food is why I put my folder to put my connection security stuff for my Wi-Fi. I watched, I can't remember where I got that from, but anyway, I stole that from one of the other students, and I thought that was funny. I'm going to go ahead and do that. And then on our Pico W, and the reason why we get these squiggly lines because I don't have it over here on the side, but the Pico W actually has a library of the SSD 1306, so I didn't really want to make more junk, well, more folders over on the side that just wasn't really useful to me, but it is for the Pico W. But the Pico W already has it, and we're importing that module, the SSD 1306 underscore I2C. You can see right here, I already put that. And then on lesson number 34, Paul wanted us to make a library, or he did make a library, and I went ahead and made a library with mine too. And you can see it right up here. It is, and I had made my HSV Color Wheel conversion to RGB value into an HVS to RGB.pi, and that's then we're calling that in, and I'm going to use it as a calling as HSV down here quicker. You'll see this is pretty much like we done through a lot of Paul's courses, bringing in our variables. We're making our variables, which is actually our pins. I like to put them in constant so they don't change. Nothing in here can make it change because it's constant. Just real quick, that's for my first. That's why 1 for my first SSD 1306. I'm just gonna say SSD. That's my first display, and then the frequency can be used for both. And this is my second display, the SDA and the SCL. Excuse me. And then red RGB pin is being positioned here, green and blue, and in this the display width and height. And then for my testing, I took some of the code from lesson 28 and threw it on here so I can be able to test to get the RGB to make sure it was hooked up correctly. I just add, so you can kind of like the type that says ignore here, but actually we can just ignore it altogether. And then we created our objects, display 1 and display 2, and it's kind of reverse order, but that's display 2 and display 1. And then we have RGB objects being created here for the red, the green, and the blue. And then we have our function coming in here. This is my function for centering the text. When you bring in anything into the argument, it will center it. And then here's my color brightness. This was my first. This is my first one to test, make sure the RGB LED is hooked up correctly, so we can kind of ignore that one. And the second one, this is the one that is actually we're using now at this particular time as it's going. That is where we're bringing these in. So the color would be the argument of our next, or from our class that we made. Right here, this is our degrees, and we're returning the color of RGB. And so that's what the color argument right here is, collecting that tuple. And you can see where I'm pulling out the information out of the tuple down here. And R LED, green LED, and B LED are for our objects of our red, green, and blue LEDs. And that's to be able to turn them on because we're doing a duty and telling them, hey, this is what we want to do, turn it on with this amount through the value that we get through our tuples times 65,535. Then this is my countdown that you can see on the display. Let me pull back up the display again. You can kind of see, well, click that button again. Over here on the far left display, you can see it counting down. Oh boy, where's that? Here. There we go. You can see it counting down right here. This is actually that formula for that. And let me back this little guy back up here where I can get him, grab him, and move him out of the way here a little bit more. Taking some time here, sorry. And then that was the countdown, so that's the formula for the countdown here. I'm bringing it in, doing a while t. T is our argument for, has a value of how many seconds we want to count down. So while it has seconds on it, clear the screen, which would be the screen on the right if you're looking at the breadboard. And then we have our information text, our green text right up here being displayed. Then we have get the date and time display. We're calling in the time and a time local with grabbing the data from. Okay, I'm getting way ahead here. I need to get down here and show you where I'm actually doing an API call. Way down here, way down here. This is what happens when you combine all 5 lessons. It gets really big. Here we go. This is where we're going to take the uRequest.get. There's multiple different types of classes or modules that you can use with uRequest, but we're taking a get one. We're saying, hey, Pico W, reach out here, and here's where you're going to reach out, and you're going to grab this data, and it's going to be a JSON data, and bring it back here to us, and we're going to go through that. We're going to sift through that. And so this is where I grab my object way down here. And then while we're here, we might as well go ahead and look down below. The main loop, and then while true, to start the timer. This is where we're adding in for that count function, the countdown function. This is the time that's being put into it. As you can see down here, start time is the variable start time when it has 5 minutes. if you want to stay within the free zone, you need to do 20 minutes within a 24-hour period, and you do 100, well, less than 100 calls, and you're not going to get charged. You're free on an open weather API calling. But first, we're doing on my local weather, and we're getting the weather, my weather, and that's up here. And we're calling that first. That was going to bring in the argument of the get weather or my weather, and we're bringing it as weather, and we're clearing the screen. I'm printing it out down here in my console so I could help divide, see what I want, because I'm going to add some little bit more for my own personal after the homework, and so I haven't got rid of that because I still want to do some things to it. And then I was printing it out, making sure everything's correct, so I'm printing it out to the console. Then I went down here, and this is where I'm putting it out to the display. So here's what the information I'm going to put in my display, and then I'm printing it out. Then I'm getting the temperature and humidity to display. I print this out to the console. I only did the temperature on the SSD because of the lack of space. I was going to do scrolling on it like I did with the time countdown. But for me, for my final, I'm going to integrate the humidity and the dew point together to give me the cloud, kind of the cloud indications of the contents, aviation background. I kind of like to look at that stuff because 3-degree spread, you start having accumulation of cloud, and I was just wanting to play with that a little bit later. And then get to time it and display it. So here's where we're calling in that time like we did up here at the top for this other one, for a countdown. And that's the reason, because I don't, when the countdown clears, I want to be able to still represent the date that we grabbed it for that day, and the day that it's being displayed. Here is this displaying the actual 24-hour period, and I'm converting it over to 12, dropping it down so we can, for my time zone, Central America, Chicago time zone. I'm around Springfield, Missouri location, so that's still within the Central America time zone. So it's -5 because we're not. Let's see here, we're not in daylight savings time yet, or winter time. Is daylight savings time? Okay, yeah. Anyway, so it's -5 instead of -6. So I would have to re-change this if I want to make this to go full time, not having to re-access the Pico W. I need to be able to indicate the calendar once it turns to the springtime, and we set the clocks back. I had to adjust that, or spring forward. Sorry, spring forward. I need to adjust that to -6 then. And then if local hours, which is the time that we're grabbing from here, if it's larger than 17, we subtract 5 for my time zone. Then we subtract 12 to be able to get it out of the 24-hour time zone indication. And then if it's less than 5, we need to add 24 to be able to do the calculations correctly, and then subtract 12 and then display. Then we can run it down and see if it's larger than 17. If it's not larger than 17, then we go down to this one, and then we just subtract 5. If it's 0, meaning midnight, we add 12, and then we change it to AM. And then I also had to adjust up here for the days too, saying that if it's less than 5, then it's actually the day before. Last night when I was working on it, it ended up going past midnight, and it was already showing the next day when it wasn't. It wasn't midnight yet. It was about 11 o'clock or 11:30, and it was already showing the next day on my display until it was actually midnight on our time. Then it was correct, but I was like, I'm going to have to fix that. I don't like that. Wow, this is getting really long. Okay, I'm going to speed up a little bit faster here. We grab that weather, and then we display it, and we grab it again. And here's where lesson number 24 was. This is mine right here for my temperature weather, grabbing in the temperature data out at JSON. Then we can convert it with the formula of 2.28 times the integer of the temperature. Instead of degrees, we're doing it by temperature, and then we add 85.57 to it. And this converts it from temperature to degrees to be used in the HSV color wheel, and then we grabbed the library of HSV, get RGB, and then add in our temperature to degree. Then once we grab that, then we use my function to be able to convert that to turn on the RGB. And then we displayed temperature also to get the weather conditions, also to display on the right SSD. And then if it's raining or any, that's going to be, you can see right here, version 2, as scrolling into that. And then it needs to be, if there's anything in the value of key, because it could be rain, snow, tornado, I forgot the whole list. There's a big list of different things, hail. All of these things would be displayed in that indication of weather, but then it's saying rain on this weather, indicating within 1 hour. I read in the documentations it says not all weather stations have that. The one that's indicating from mine, which is the Springfield, Missouri, is where this is gathered from. The ID, when I looked up the ID, that was actual indicating from Springfield, Missouri. And it does have the ability to display the precipitation. And then we did the winds, and it converted it to what direction for degrees. And then we return weather, so I can use it on the countdown to be able to display the date. And then here's my credentials to be able to set up. This is where we call to set up the server, and then activate the server for it to work. And then we push our credentials over to the Pico W, saying, here you go. This is how you'll send this to the local Wi-Fi and log in. And then if it's connected, it'll say print out connect on the server. I was going to do that like I did on lesson 28. But I noticed that when I was practicing with that, when I did it at first, it just flashed so quick because it would just immediately reconnect. But now since I have it on power, or battery mode, it's taking its time to connect. So there you go. And then I talked a little bit about the loop already. So here we go through the loop. We can adjust it to our time to be able to do this, and our display. Since I'm not connected to the laptop, I cannot show you the changing of the RGB. But doing the math, it did. And let me pull that camera up real quick and let me see something here. I'm using. There it is. And let me see, pull these guys back. And pull this back. Hey. This is similar to those who watched on 33. Paul did our, it really does not come in very good here. And oops, I'm doing it the wrong way. Alright, this is, instead of laying it on top of each other, I wanted to separate them. And so here's where I separated them all down. And this is what the value that I said, if you followed along with Paul, he gave you what you needed to do to actually do out the formula. And then, lo and behold, what I did was pretty much what Paul did on lesson number 34. You need to find out what's going to be on, what's going to be off, and what needs the formula. And so we know here that within our slides, well, let me get down here where you can see my finger better. We know down here within the slides, we're going to have to do a formula, because that's just like what he taught us with a lot of other different things, with the analog value of a slide slope, or slope point indication. Slope point indication formula is what we're going to be able to convert that to, which is y minus y1 equals m, where the value of m would be with x minus x1. And that's our point slope indication. And that's what you're going to do with these slopes. So that's what I was showing up here, that, hey, these are off. These are ones down here. Like Paul was pretty much teaching us on that course. These are off. These are going to have the formula. These are on. So that's ones and zeros. Ons and off. So zeros and ones. And Paul pretty much, if you were paying attention, he wrote those on there. And it was kind of just like, wow, hey, Paul's pretty much doing this for us. And he's already showed us how to do the other math for the slopes. You just need to figure out if it's a positive or negative. And so this would be, when we're coming down, it's going to be negative. When we're going up, it's going to be positive on our values. And so, we have to indicate if it's positive or negative on our formula down here. And then we figured out our y2 minus y1 over x2 minus x1. That equals our m, so that's our slope indication. And then we need a point slope formula to be able to convert that over. And when you do all of that, you get the value that we have, or that we use. Well, it's up here. There we go. It's right here. So then we get the value that we need for right here. And I tried leaving it as a non-decimal, and it would not come out correct. And so maybe I saw where Andrew had posted, why, Paul, are you going ahead and dropping it all the way down to decimal? And maybe because Paul knew that it wasn't going to come out right, or maybe it was just me. Maybe my math, when I was typing it out on the calculator, trying to use a 120 degrees temperature-wise, needed to be 360 degrees on HSV, and it was not working when I had it in a fractional form. But when I put it in decimal, lo and behold, it worked. So there we go. Sorry, this is long, very long-winded, but that's what happens when you combine 5 homework lessons into one. Just wanted to make sure I got it all out there. And thanks for tagging along and letting me explain it to you, and seeing how I did it, and enjoy my little fun with it. Until next time, everyone, be safe out there. Thank you.